Now we will define the conditional PDF given an event. So for example, for continuous random variable let A be a subset of the real line with probability of x belonging to that subset greater than 0. Then the conditional PDF of x given that x belongs to that subset is given by this. The conditional PDF of x given that condition, x belonging to that subset, is equal to we have the marginal of x over the probability that x belongs to that subset for x in the subset, and 0 otherwise. Okay, let's see this example. Consider random variable x with PDF given by this formula for x be between 1 and 2, and that means a 0 otherwise. I'll have to find the conditional PDF of x given that we already know x is greater than 1.5, and then we have to find the expected value. Okay, let's see. We have that the PDF has this form. We have x here. Let's say this is 1, this is 2, this is f of x, and 2, we have 2 over here, 1, and this is 1.5. The distribution looks something like this. So this is the PDF, sorry, for x. Now we have to find the distribution of x given that x is greater than 1.5, right? Evaluating x. Using the formula, we know that this is given by the marginal of x over the probability that x belongs to a subset. In this case, the subset is given by the values of the random variables that are greater than 1.5, right? And the super is for x that belongs to the subset, right? In this case, the subset again is that is greater than 1.5. Okay, the marginal is 2x to the minus 2. And here, this probability, what we can do is to calculate probabilities like in the same way as we have done before. This is 1.5, and we have to calculate this area over here. So to calculate this area, this is probability of x greater than 1.5. It's basically the integral from 1.5 until 2 of the PDF, right, of x. So this probability is going to be the integral from 1.5 until 2 of the PDF, that is 2 times x to the minus 2 dx. And this is going to be for x. Well, the marginal, remember, that is for x between 1 and 2. So this is for x greater than 1.5 but less than 2, so it's for x between 1.5 and between 2 as well. And the answer for this is going to be, this integral is 1 over 3, so this is 6 times x to the minus 2 for 1.5 less or equal than x less or equal than 2, and 0 otherwise. Okay, now to calculate the expected value, and let's do it here. And expected value of x given that x is greater than 1.5. Well, we are going to use the PDF of this random variable, right? That is 6 times x to the minus 2, and it's basically, oh, sorry, is basically the integral for this support, that is 1.5 until 2, of x times this PDF, again, that is 6 times x minus 2 dx, and if we do that integral, this is 1.73. That is the expected value of this conditional distribution. Now, that is for now. Let's speak about independence in next video.